All right, good afternoon, folks. So today's going to be general C sharp. That basically means no Unity stuff. We'll save Unity for, at least Unity's interaction with C sharp for next time. So that'll sort of be C sharp the Unity way. Today it's just general C sharp. C sharp is a general programming language, so just like something like Java or C or various other languages, Python, JavaScript, depending on how you use it, you can pretty much do anything with it. So it's not a specific language for Unity. It's just a regular language that lots of people use for lots of different situations. So most of the concepts, and that's sort of where we're starting with the with the lecture. Most of the concepts are very similar to Java. The syntax very similar to Java. So most of what you're going to see today should be familiar. There shouldn't really be any concepts that are brand new. There might be a couple of sort of things that maybe Java does automatically that maybe you have to be a little more manual with in C sharp, but overall, really we're not doing anything with C sharp that you didn't see in something like CS2, for instance. But you will need to pay attention because there are subtleties. There's these subtleties that are easy to miss. The nice thing about sort of knowing a language like Java sort of well enough at the moment, or potentially other languages as well, is that you will probably know what you want to do. So if you say, okay, I want to make this class and I want to make this an abstract class, how do I inherit that? So then you could easily go on Google, say C# inheritance. So as long as you know the concepts, understand the concepts and how you want to use them, it's relatively easy to look up how to do it in C#. And really, this is how you would learn most sort of new languages. You know the concept, you check and see if that language can do that specific concept. In the past, probably like I don't know, Unity 4 and 5, sort of way back when, there were multiple languages that Unity supported. C# has sort of always been there. There was also like a Unity sort of scripting language, kind of like Godot has their own sort of scripting language. There was a similar one in Unity, and I think you could use like a JavaScript type language as well. These days, they've basically gotten rid of all that, so C# is the language that you have to use to write scripts in Unity. In Unity 2020, I'm pretty sure they added it in one of the most recent 2020 releases. They do have a sort of scripting, sort of a visual scripting language called Bolt. So Unity, the company bought Bolt, and so they've integrated some of that stuff in. That's still sort of preview, so it's not sort of full-featured, fully available, fully tested, all of that. So we're going to stick with C# writing our scripts. Most languages have their sort of current standards. So for Java, that's like 12 or 13 or something. They're working on 14 or something like that. For C++, the standard is, I think, 20. I think they've sort of finalized C++ 20. It's the same for pretty much all languages. C# is the same way. I don't know what the latest version of C# is. I think it's like 8 or something. Unity does not always implement the latest C# standard. So if you see some brand new feature, let's say you're looking around on the internet, you see that C#, whatever, sometime in the future, C# 10 is going to have this cool new feature that'll make things a lot easier. That does not guarantee that Unity is going to support that. That's something that you will want to check on. Potentially, Unity may not support a brand new feature in a C# standard until like years later, potentially. That's sort of typically the way these things go. So don't expect the brand new features of the language that you hear about to be ready to go in Unity right away. Since we've used Java most of the time, Oracle is sort of the corporate backer of Java. There are other implementations, so Amazon has Corretto and stuff like that, but for the most part, Oracle is the sort of the main corporate backer of Java. It used to be Sun Microsystems way back in the day. Microsoft is the backer for C#. So most of the features you see will be very similar. You're going to see lots of similarities between Java and C#. They're obviously both C-like languages, but even some of the terminology and sort of the way that they do stuff is very similar. So they basically do the same type of thing. It just depends partially on what kind of ecosystem you want to be involved in. It is a compiled language. You can do some interpretive stuff with it, kind of like how Python works, but I haven't looked into that as much. Whereas, of course, Java runs on the JVM. So there's sort of a compilation process there, but you need the JVM. C# isn't exactly the same sort of thing as that. So that's sort of the basic sort of overview of sort of where C# sort of sits when it comes to Unity and Microsoft and all that kind of stuff. I do like C#. I mean, it's pretty close to Java. If Unity was Java or something, then it would probably work mostly the same way. So you're not going to see tons and tons of similarities. It's just some syntactic differences that you won't want to pay attention to. So again, today the focus is on just general C# independent of Unity. On Thursday, we'll look at how the Unity engine and C# work together. So it's not sort of a simple, if you know general C#, you'll be able to run to do stuff in Unity, because Unity has some specific stuff. It's sort of a C# the Unity way is sort of how it works. I don't expect today's lecture to be super long. I will be doing some coding stuff. It'll be totally Unity independent. I have a C# sort of project set up in Visual Studio, or Visual Studio Code. You can easily create one in Visual Studio as well to mess around with some of this stuff. But I'll show you some of these features as I talk about them as well, but they are sort of all in the slides. So you have your standard types, your standard sort of basic variable types, ints, floats, doubles, chars, booleans, and strings. There's a couple things to note here. If you use a float, which is very common in Unity, you will have to put an F after it. So if you just have something like here, like 5.9, if you just put 5.9, just like in Java, it will treat it as a double. So a double is here on the right-hand side. If you want it to be a float, you would put 5.9 and a float and F. The difference between float and double is that floats are only 4 bytes, whereas doubles are 8 bytes. This is important when you're programming, particularly something like a game, particularly something on a sort of more restricted system that has less memory available. Floats are the common thing in game dev stuff because it's half the size of a double. And when you have arrays and potentially millions of values that you need to keep track of in structures like arrays, floats are going to save you half the space as compared to a double. So doubles are not commonly used. They're not needed because do I really need 16 decimal places of precision for most stuff that I do? No. At least game-wise, no. In sort of the science aspect, the sort of nuclear physics stuff I did, yes, we use doubles all the time. Sometimes we'd even use quad precision if we needed it. But for video games, floats, or even less, so a 2-byte float, for instance, is usually good enough. Characters, same thing as Java. Single quote for them. Booleans, of course. Booleans are not totally spelled out. It's just bool. Strings do not have a capital S. They are still effectively objects, so they have sort of extra stuff you can do with them, but there is no capital S. So that's a very sort of subtle thing that that you can easily forget. And of course, it uses the double quotes when you create a string. So not a whole lot of differences here, just a couple of little things that you might have to remember when creating strings or when using floats. There is for regular typecasting rules. There's implicit casting and explicit casting as well. So the implicit stuff is automatic. You don't have to do anything special. So taking a char to an int, or an int to a long, or a long to a float, or a float to a double, this happens automatically. Your explicit casting is when you have to do it yourself. So if I want to go from a double to an int, I need to do the cast myself. So it's a couple of examples of the explicit casting here, taking my int and doing a cast to int of a double, for instance. So we have a double, we cast to int that double, and we save it to an int. It's the same thing that you've seen in Java, that you've used in Java. There is also a convert class that you can use. So it's just, all these functions are static, so you can just say convert dot to string and change a value. So in this case, my int, or change it to double, or change it to an int32, or change it to a string. It doesn't matter. You can use this convert class. It has a whole bunch of functions. They're all static, so you don't have to create a convert object, and you just use the to whatever type you want to go to. So this is something that's quite common if you want to be explicit about what is happening, what you're doing the conversion for. Otherwise, you have the automatic or the explicit casting. So it's up to you what to use, if any of these. Operator-wise, basically the same as Java. You've got all of your addition, subtraction, multiplication, your increment and decrement. You've got all of your sort of shorthand assignment operators, so your plus equals, minus equals, all of that. Your comparison operators are all the same for equals, equals, not equals, all that. You've got your logical operators for and or and not. So these are your very common ones that you'll throw into if statement conditions. There's also bitwise operators as well, if any of you have used those. One of the colloquiums I gave over summer, I talked a bit about bitwise operators in the context of the fluid simulation that I did. So if you've never used those before, that's fine. You probably won't have to. They're relatively rare unless you're doing something very specific, but they do have those as well. Control flow, basically the same thing that you're used to. So the next couple slides just show some of the pieces of this. So you've got your if, else. You can just have an if, you can have an if, else if, you can have an if, else, all of that normal stuff that you're used to in Java. So you got your conditions here. There's also the ternary operator. It's the same as the one in Java. You may have never used this before. In fact, I wouldn't be surprised if you may have never seen this one before. This is basically just an if, else, but it sort of does an assignment as well. So you're saving some variable, you put the condition in. If the condition is true, so you have this little question mark. If the condition is true, or the true condition is here, the colon false condition is here, and you sort of save the whatever value is related to the condition and the expression being true or false to the variable. It's just a shorthand essentially for an if-else. That's really all it is. So you don't have to use these. You don't have to use a ternary operator, but it does exist. So if you see something like this in, say, code you're looking at, or potentially in any of the code that I write, it is really just an if-else. You got most of your standard structures that you've seen as well, things like switches, where you put a bunch of cases in. You also need the default case, which I think can be optional, although I don't use switches all that often. You got your while loops, you got your do while loops. The break and continue statements work just as you would expect. So break will take you out of whatever loop you're in. Continue will move you to the next iteration. For the for loops, essentially the two most common ones that you'll use are your sort of I equals 0, I less than whatever, I plus plus, and execute your stuff. Or we also have the for each. In Java, the for each is not spelled out as for each. You would just use a for and then have a different condition type in. For C#, you'd actually type for each. So you say for each, and then you put the type. So for each, I don't know, string S in some string array, you can do stuff. So it's the same sort of for each loop you're used to in Java, same sort of stuff for basically all of these control flow things. If you've never used a switch before, that's perfectly fine. There may or may not be one, and I don't remember in some of the code that we use for the class, but essentially it's just a similar way to do sort of a branching type thing, sort of an if-else type thing, but overall sort of faster, but maybe a little bit less intuitive. For each essentially can be used on any array. If you remember back to CS2, for each typically needed to be used in Java. For each is typically used on anything that implements an iterator. So it's a similar type of thing here in C#, but of course all that's sort of hidden behind what arrays actually are. Again, none of this should be surprising. None of this should be like, oh, I didn't know that existed, because this is so close to Java that there shouldn't be any problems here. String-wise, there's sort of normal stuff that you do with strings. There are a couple of differences, though. In order to write to the console in a regular general C# program, it's just console.writeLine. So similar to system out printf, for example. Creating a string, again, there's no capital S, but you just create a string like normal. There's methods that can help you out, of course. So things like length, things like to upper, to lower. So to change the string to all uppercase, change the string to all lowercase. Notice that the first letter of all of these methods are capitalized. The standard C#, the standard sort of C# style for most things is Pascal case. So to have these sort of uppercase letters for everything. Depending on how I'm feeling on any given day, I might just do what we've normally done in Java, which is probably what's going to happen throughout the class. But sort of the standard style is to have uppercase for all the first letters in methods. Concatenation is all normal. So take two strings, you can sort of add them together using the concatenation. Printing out variables is different. The caveat here with this particular string is that this will not work on any version of C# that is less than 6. So C# 6 was when this was implemented. I don't exactly remember the syntax for like C# 5 and before, but you had to do like extra stuff to be able to print out variables in a string. So in this case, it's creating a string with some variables in them, so similar to like a string.format in Java, and then you can print that string out. So it does need the $sign here. That is not a typo. And then whatever the variable name is, you put that in curly brackets. So anything past C# 6, which I'm pretty sure Unity supports, but maybe we can check on that on Thursday to make sure that works properly. But this is your sort of standard way to put in variables into a string. That's similar to something like printf or string.format. Strings are sort of implicitly arrays, so similar to sort of handling to Java. We can take a look at the various individual characters in a string, and then we can also check with a method called index of, where is the index of a value that is of a character that's in the string. This will find the first instance of that variable and give you the index. So it's pretty standard stuff. Even if you don't remember these, which I don't expect you to, you can always type the name of the string dot and then look through the list of stuff that is available to you in the autocomplete. And so you'll see, oh, length, yeah, of course. Or to upper, okay, that makes sense. That's what I'm going to use. So I don't expect you to remember all this stuff. Probably the biggest one here, the biggest sort of difference between Java and C# is this one. Just remembering that if you want to print out variables in C# 6 or higher, this is the way to do it. So I'm going to flip over to my VS Code project here real quick when we start talking about classes, and I'll make sure to do some printing like this as well. There are regular escape characters too. So if you need to print a double quote, it's always just using backslash, for example. So if you want to print a backslash, it's backslash, backslash. New lines, tabs, stuff like that. So the escape characters, basically standard stuff, but they're not the percent and then the character for like percent new line. You just use the /n. Arrays, basically identical. There's pretty much no difference here. You can declare an array, and it won't be anything at the moment. You can use the curly brackets to create a sort of a statically sized array of strings, of numbers, whatever you need to. To initialize the array, you do something like this: int brackets, whatever the name is, equals new int, and then the size of it. So creating an array, very easy to do, same thing as you see in Java. So in this case, looping over the arrays, you can either use our standard for loop, I equals 0, I less than the length of the array, and then do whatever you need to do. Or you can use the for each. So that's our for each string s in cars. So hopefully this makes sense. There's lots of other methods associated with arrays as well. It's got sort methods, min, max. So if you have arrays of numbers, min and max. Sum of everything in the array. These typically are fast. Most of the time, the sort of internal functions, the sort of internal stuff that languages have, are typically faster than what you could write with your own functions. It depends on the language, depends on exactly what you're trying to do. But for the most part, the internal ones are going to be fast. They'll be highly optimized, all that kind of stuff. So if you do need to do something where you need the sum of all the elements in some array, then using the sum function should be a very quick way of doing that. Methods, for the most part, everything follows the same naming conventions. Again, C# typically uses Pascal case, however, for method names as opposed to camel case. So you will see that when we are using some of the Unity built-in methods and stuff like that. To me, it doesn't matter what you use as long as you're consistent. So methods are pretty standard. The static keyword is the same sort of idea as in Java. Typically, stuff starts with main. It's a capital M because of how C# likes its Pascal case. And then you just call methods like normal. If they have a return type, you of course save that into some variable. In this case, this method just prints something out, and we'll write a few methods when we write classes. Parameters, they're going to work just like you would expect. In this case, it's taking in a string and concatenating it, and apparently I spelled this wrong. But yeah, so it's just your general sort of method stuff that you've been used to from Java. C# has something that Java does not in terms of methods. There are default parameters. So as an example, this method here, the my method, it takes in a string called country, but it also, you can see it also looks like it sets it to USA. And it just writes that string out, writes the country string out. So you can call this method just like this. So I could put UK in, and that would print out UK. And I put Germany in, it prints out Germany. If I don't put anything in, it uses the default parameter, which is USA. So this would print UK, Germany, USA, Canada. So you can sort of mimic this in some ways in Java, but Java explicitly does not have default parameters like this. Other languages do. If you use like Python and stuff, they have default parameters. So you may have seen this before when using other languages. C# has it. I've never had a major reason to use it, but potentially it could be useful in some situations. If you have a real complex method, for example, this can actually be confusing, because if you're calling the method from somewhere else, say somewhere deeper in your code, it may not be obvious that there's a default parameter that's getting set unless you really go dig through your code. So to me, it can be a little confusing if stuff starts to get sort of large, and then you're working with these things that have default parameters, and maybe you don't remember, and so it can be a little bit confusing depending on the situation. Overloading of methods is of course allowed. So we got a plus method and a plus method, different parameter types. Same rules apply as in Java. The return type, if that's the only thing that's different, that does not count. So it has to be a different number of parameters, or the parameters have to be of different types. So in this case, just standard overloading of a method. So that is perfectly fine. And then we get to classes. So this is the most complicated part here. I am going to switch over to Visual Studio Code to illustrate some of the class stuff. I want to mention a couple things first. Same style as Java. Typically, you're going to use just one class per file. That's not a sort of a hefty restriction. In two of the programs that we write, two of the games we write, we will have a state machine that has all the classes all in one file. But for the most part, people still use that convention of one class per file. The access modifiers that we have available to us are public, private, protected, and internal. If you don't put a type, I think technically it is internal. Internal is something that you'll probably not use. It is kind of like package private in Java. In C# there's these things called assemblies, and you can make your code part of assemblies. Internal means the variable it can be shared within the same assembly, but not across assemblies. So similar to packages in Java. So typically you're just going to use public, private, and protected. Internal is probably not a very common one. So let me go over to, I think the next thing is, some property stuff. Okay, so I'm going to go over to Visual Studio Code. And we're just going to start with the basic sort of program sort of project. The stuff that's over here in my sort of folders and whatnot, that is basically how the project is organized. Say you go into Visual Studio, the sort of actual Visual Studio, and create a new console project. This is sort of what you're going to get. You don't really ever have to do this. It can take, at least Unity-wise, you don't have to do this. It can take a little bit of configuring, because there is a C# compiler. Just like for Java, there is a Java compiler called Java C. The C# compiler is called CSC for C# compiler. So you may have to configure sort of where that is and go locate it in your file structure and all that kind of stuff. So you don't have to do this. You don't have to follow along. Unity takes care of all this stuff for you when you're using C# and Unity. But I just wanted to show you some of the general stuff related to C# without Unity, just separate from Unity, so you don't have to. So we don't sort of have all that extra Unity stuff that is sort of attached to this. So the very simple console application would be a console write line. There's also write, but typically you're probably going to use write line, and we'd say something like hello world. So running this is a little bit more complicated in that we need to compile first. So I already have CSC set up. So this is my compiler. I can put the exe on, or I don't have to. This is just PowerShell in the terminal. And if you've ever compiled Java before, that's going to look somewhat similar. And then I can run the program in the console just like this, and I get hello world. Again, you don't have to worry about doing this, but this is just how you would do it if you were using C# as a regular compiled language. If you were in Visual Studio, there's of course a run button, and you can set that stuff up here in Visual Studio Code as well. I just decided to do this through the terminal today. If we wanted to throw in a variable, so say I had an int, I don't know, called count, and I had that set to 5. If I wanted to print that out in here, I would need the $. And then in here, I would have the curly bracket, and I would say count. Just like that. And we'll compile and run, and there's the 5. So it's not too much hassle to do this. It's just remembering that, oh yeah, you gotta have that $. That's a very easy one to forget. In the highlighting scheme that I have here, it does change the highlighting when I don't have it. So in this case, if I don't have the $, it tells me here the variable count is assigned, but it's never used. That's related to this, not related to the print. So if I do the print, it's just going to print out this count here. So it's just going to print out verbatim what I have. So that $sign is absolutely necessary, and you can use this kind of string creation in Unity as well. Okay, so class-wise, I'm going to keep this class program here with main, but I'm going to create another class, and we are going to look at inheritance as well. So I'm just going to create a class here called parent. Constructors basically work the same way. So I'll create a public constructor called parent. And this, maybe it takes in a value. And a parameter that I can put in here is private. Actually, let's do protected, because we'll make a child class of this in a moment. And I'll call this value as well. Protected int value. And then I'll say this.value equals value. This should be familiar. This.value is specifically pointed to this guy. This value here is sort of hiding the value that's up here, but that represents this one. So this should be familiar for stuff that you've seen in CS2 and hopefully other classes as well. Maybe we can have a print method. I'll show you toString, because that is a thing here as well, but it's slightly different. So we'll make a method. So this will be public void print, and we'll just have it do the console write line and print out the value. And we need the $sign. All right, so basic class, easy class to deal with. We can come up here, we can create one. So we can say parent P equals new parent, send in whatever, a 5, and then do P dot print. So I'll compile and run, and we see the value is 5. So standard class stuff. You should be able to do this, to come up with this stuff very easily. Now, there are a few things we can do for values like this, and in the slides for our actual fields. And in the slides here, I've got a couple examples of that here. These are properties. So of course, a private variable can only be accessible within the same class. A C# property, and this is something that doesn't exist in Java, a C# property is like a getter or a setter. In CS1 and CS2, when I teach it, I talk about getters and setters. And oftentimes you will have lots of getters and setters for particular variables that you need to have access to, even though, say, a variable is private. With C# properties, it's the same style. It's the same thing, but it's a lot less code that you have to write. So take a look at name here. Take a look at name. So we have a private field called name, and we have a public property called name with a capital N. These are different. The case matters here. For the property, we can actually put brackets after it. So it kind of looks like a method, but there's no argument list. And then we say get and set, and we put what we want to do with the get and set into brackets. So if we want to get the name, it's just going to return the lowercase name. If we want to set the name, it's going to say name equals some value. This might look a little weird, but I'll show you how to use it as well, and I'll show you in our actual code too. But here's sort of an example. We were creating a new person. We can say myObject.name with the capital N equals my name, Micah. So we're setting here, and if we write out the name, it's going to do the get. Michael, yeah, I think so. I haven't used the dark areas of Python too much, but I think that's where some of the inspiration came from for stuff like this. So this is directly creating a property. Oftentimes, things like Visual Studio, just regular Visual Studio, will actually let you right-click on the name and just say create property, and it'll automatically put this stuff in for you. I don't know if that's might not be able to do that in Visual Studio Code without some other extension. I'm not sure. We can try. The other way is to make a automatic property where you can write even less code. So I can just say public string name get set, and it just automatically does this same thing. The nice thing about this is you have a little bit more control as to what you can do with the variables. So if we go back to here, let's create a property out of value. So I'd say public int value, and I put my brackets in, and then I would say get, and we can show this here, so we can say return value, and then I have set, and I would say, let's check here, yeah, it should be fine. My value name might not be necessarily great for this because yeah, let's change this. There's typically you would write something like value equals value, which is actually not what we want to do. So let me just rename this to count. Do something like that. There are renaming features in here, but I'll see if I can get a shortcut thing so so you know what shortcuts I'm using that'll pop up on the screen, because I don't want to have to explain all the shortcuts that I use for this. Okay, so this will work for our variable that we create. So I can do something like this. I can say console write line, and I can say p dot count like that, and it will use the get that I wrote as part of the property. If I don't have a get, That's perfectly fine as well, but now I get a problem. It says it can't be used as context because it lacks an accessor. So it doesn't have the get property, so I can't use it. I can still do the set though. So I could say p.count equals 3. I can still do this. So that works fine. So I have a little bit of control. I can say you can set it, but you can't get it. Or other way around, you could get it, but you can't set it. The sort of standard sort of property stuff where you don't have to put this extra code in here if you want, it would just be a get and set. So that will work as well. Same style. If I don't want to be able to set, then I can just get rid of it, and it would just have a get, and now I would get the error that's here. So these are useful if you need getters or setters for your variables. This is an easy way to do it. You don't have to. You can still write getters and setters if that's what you're used to doing. That's perfectly fine. But C# gives you an option to do this property thing so that you can reduce the amount of code you have to write, and in principle, reduce the amount of methods you write and the potentially commenting you have to do on what those methods do, all that kind of stuff. So this is the idea of properties. So one of those things that Java does not have. All right, inheritance is the most, probably one of the most different things in terms of syntax. The concepts are the same. There's an abstract keyword, of course, that you use. Means the same thing that you're used to in Java. Inheritance, however, is done via a colon. So there's no extends or implements or any of that. Overridden methods must have the override keyword as part of their signature. So those are some big differences. So let's go back to the code. And we're going to make another class. Let's make this parent class here. Let's make that abstract. So we can show some polymorphism as well. So now I cannot create a new parent because parent is abstract. So it's the standard stuff here. Cannot create instance of abstract type or interface parent. So I'll need to change that. And let's make a class called child. So class child. If I want this class to inherit parent, I need to use a colon, and then I can put parent, and then my brackets. So now child is if you sort of drew our inheritance diagram, child would be below parent with an arrow connecting them. Now, I have an error. This should make sense. You should be able to see why I have this error. It says there's no argument given that corresponds to the required formal parameter value of parent.parent int. This is a constructor problem because parent has a constructor that takes an int. So normally in Java, you would do something like this. You'd create a constructor for child, and maybe it doesn't take an int. Maybe it's just going to be empty like this, and then you would write like super 5. The reason why it's doing that is because there is no super keyword in C#. So you'd write super 5 like this, and then you'd sort of do whatever other stuff you needed to do. That is not how it works in C#. The concept is the same. When the child constructor gets called, the first thing that happens, just like in Java, the first thing that happens is you make a call to the super constructor. So I'd make a call up here to parent. But this is not how it works. This is not the syntax. Base is the syntax for doing things in the base class, but it's still not the syntax. The syntax is this. Right here in the actual line for the constructor, you do a colon, and then you say base and whatever else you want to put in here. So base 5. So it looks a little strange, but this is saying when I call child, the very first thing that happens because of my inheritance is I call the base constructor with a value of, in this case, 5. So anything that you would put in super in Java goes colon, base, and whatever you want to put in here. If you want to call a second constructor in the same class, so remember we can have more than one constructor. If you want to call a second constructor in the same class, you would use this, just like you would in Java. Right now, the error here says child does not contain a constructor that takes one argument. So that's why this one doesn't work here. But this is your sort of normal usage for the constructor that you need to call during the constructor chaining process. So the concept is exactly the same. The constructor chaining still happens. It's just a different syntax when it does. So that satisfies our sort of creation of our class. Let's say, for instance, that we have another method in here. So I'm going to put another method inside of parent, and it's just going to be public void update, and maybe that takes another int. Maybe we can have this be amount. If I want this to be abstract, I just use the abstract keyword. So now child is forced to implement update, just like in Java. So notice I have the error on child now. It says does not implement the inherited abstract method. It does have no quick fixes available. There's probably something I'm missing somewhere, some extension somewhere, something that will show these to me. In Visual Studio, that stuff's all sort of set up for things like C#, so that should exist there. So I need to add this in. So I would normally, in something like Java, you would say, okay, public void update AMT, or int AMT, and then you might write something like, I don't know, this dot, we have the protected count here, this dot count plus equals amount. Okay, great. But notice we have a warning on update. It says child update hides inherited member parent update. To make the current member override the implementation, add the override keyword. Otherwise, add the new keyword. We will use override and the new keyword as we go through the semester on a method. It might sound kind of weird. Throw the new keyword into a method like this? That seems really weird. There's specific cases where you might do this. We have to have override. If you are overriding a method from a base class, you have to use override. In Java, we have the annotation that you can, but you don't have to use the @override. In C#, you have to use override if you intend to override a method. This is an abstract method, but what about print? What if we wanted to override print? So let's do that here. Public void print. And maybe we just want to print this out, but we'll say something slightly different. So we'll say child value or something. We get the same warning, hides inherited member parent.print. Use the new keyword if hiding was intended. So we can put the new keyword in here to sort of fix our warning. But this isn't what we want. We actually want it to override this, which means we do need the override keyword. But as soon as I put that in, I get an error. Cannot override inherited member because it's not marked virtual, abstract, or override. This is a new keyword that you may never have seen before. We need to put in virtual. Virtual says this function exists and it can be overridden in child classes. So if you intend for a function to be overridden in child classes, but you want a default implementation, then you have to use virtual. We will be using virtual in a lot of our stuff, particularly in our state machine classes. So abstract works the same way. You have to use override to say that you're overriding it. Virtual is just essentially an abstract function that has an implementation. So it's not really abstract, but it's the same idea. It's just that it can be overridden, and then you use override. So these are subtle. These aren't things that are usually going to trip you up. It's just remembering, oh yeah, I got to use override if I want to do this. Abstract is normal. Virtual if it has an implementation. So there's a lot of these sort of little things that potentially could cause problems or that you could forget. And pretty much switching between sort of any two languages, you're going to find a lot of stuff like this. I think there was a couple other things I wanted to mention related to this sort of style here. Let's actually do a little bit of polymorphism here. So I'm going to say parent P, same sort of thing you do in Java, but I'm going to say this is a new child. Child does not have an argument for the constructor because it just calls base 5. And if I change this, maybe I change this to 10 or something, then I can compile, run, and I get that the child value is 10. So p.print is doing all of that normal dynamic binding stuff that you're used to in Java because it's seeing that p is actually a child, so it looks to the child first and does the actual print. Same thing with update. Of course, it's updated as abstract in our parent, so of course it would use this one. So you get your sort of standard polymorphic stuff. One of the things, I don't think I have this in the slide, in Java, you're sort of used to something like instance of. So if I want to say p, if p instance of child, for instance, like something like that. We would sort of use this to determine what it was an instance of. Maybe you do a print. So something like this, and you'd say yes, or something, or whatever. Instance of does not exist in C#. It's even simpler. It's just is. So if p is a child, print out yes. And p, of course, is a child, so I should print out yes when this runs. So here is yes. If we put in parent, we can check as well. The result here should be what you expect. Yes. Child is a parent, so if I use if p is parent, the answer is also yes. If I put something else in here, let's say I put a string in here, it does give me a warning. It's because the linting stuff, the OmniSharp, the thing that is used to figure out if you have errors or not, actually already knows the answer to this. The given expression is never of the provided string type. So it already knows, yeah, p is never a string. That's basically what it's telling me in the warning here. And of course, if I run, it's going to give me that warning as well, saying, hey, this is never going to be true. And of course, when I run the program, it does not print out that yes. So it's the same idea as instance of, it's just is in our case. So if you need to use that for when you're doing some polymorphic stuff, this is how you go about it. You just say is. You may also see as. As is also another similar one, but it actually does a little bit more work. It does the is check, and then it actually does the cast for you. Remember in Java, we would do an instance of, and then we would have to do the cast right after for like creating our own dot equals method. As does the cast for you at the same time. So it checks, does it work? Let's do the cast if it does. So as can also be used. The reason why this errors out is because you don't typically put this in an if statement. It doesn't. It actually returns something to you. It doesn't. It's not a Boolean. So as is another one that you may see, but is the instance of equivalent. So something like child. I don't think I had that one in the slides, but I do think it's worth mentioning. There are also interfaces. Interfaces are very common. We use them a little bit in CS2. It's mostly the same exact type of content. So things like you create an interface. This, if you have a snippet or something, you see that it'll create a little bit for you. Typically, a capital I is used as the first letter, and then of course you have whatever else you need here. So we could say something like animal. So it's an interface. It represents an animal. It's the exact same idea as in Java. You create a function here. I think in the slides I have like make sound or something. So something like this. This is abstract. Make sound here is abstract, and it is public. So same idea as Java. To implement an interface, you simply have a comma-separated list. So I can say I, animal. In this case, I have to implement make sound. Now this is where it can be a little bit different. So I can say public void, how do I name this here, make sound. Notice I don't need override. It's one of those little things. If it's an interface that you're sort of overriding the method, then you don't have to put override, and it'll work just fine. There is no multiple inheritance in C#, so you can only have one class that you inherit from, and then of course as many interfaces as you want to implement. So same sort of style as Java. The capital I is useful because then it tells you immediately that, oh, parent is a class, animal is an interface. So that's why you will see it in there, and for the most part, we'll sort of follow along with that style. So it's one of those little things. You don't need an override. Okay, awesome. I kind of wish it did need an override because then to me that would be more consistent. But whatever. It's C#. So we will be using these. We'll have some in our third game. We'll make some that are related to the factory method. So that's the factory pattern. So that's something that we will do. Okay, so back to the slides. Here's the interface stuff. So similar to what I just did. If you just want to implement the interface, you can just put it in there. You don't need a class to go along with as well. There are enums too. We will have some enums now and then, particularly in our state machine. So they're basically just a class that contains constant values. So you just put in some names, and behind the scenes, each one is represented by a number. If you've used enums before, great. They work the same way as you're used to in pretty much all languages. If you haven't used enums, that's fine. This is basically all they are. If you print out the value of an enum as an integer, it just gives you that behind the scenes integer. So we will use some enums along with our classes when we create a state machine for the first time in the second game and in Talk About Game Programming Patterns. Exceptions are basically identical. Try, catch, finally. So these are the same sort of stuff you see in Java. Whatever exception, there's a whole bunch of them. You can throw your own exceptions if you want to. So in this case, throwing a new arithmetic exception with whatever the message you want to be displayed. So very similar to Java. So nothing special there. And that's basically it. I hope that you sort of recognize most of the stuff, particularly the concepts. The actual implementation of those concepts, especially when it comes to inheritance, is definitely a little bit different. So if you sort of have forgotten any of these things, that you've forgotten about dynamic binding and how that works and interface stuffs or whatever, it's worth brushing up. I would brush up in Java since that's probably where you first saw a lot of this stuff. And then, of course, you can always look up exactly how to do the specific things in C#. I think I covered most of the sort of differences that are going to be impacting us when we write our classes. So on Thursday is more C#, but more of the Unity way. So before you take off, does anyone have any sort of burning questions related to this sort of general C#?
Yeah. I was just wondering, is there like a site, like I know there's like HackerRank and like there's Khan Academy for like basic stuff. Is there a site you'd recommend for like if we were just trying to practice all these concepts before we got into the class?
I'll throw something up on Blackboard. There are a couple. I've been to a couple before that have been like a Java to C# type of sort of website, like, oh, if you're good at Java, how do you transition to C#? So I can see if I can find where those were and post them up. So give you potentially a different sort of look or a different sort of outline of this from what I showed today. As far as there's one other thing I wanted to mention that I forgot about. I did post up the VS Code sort of some of the extensions that I have. These are pretty standard. things like debugger for Unity and Unity snippets is quite useful. I haven't used a debugger basically at all, so I don't know exactly how well that works. But these are ones that could potentially make your life a little easier. The Unity snippets is nice, however. And then just a couple other things. If you see me typing stuff and you see something weird happen, I am using JetBrains Mono. So if I do something like a less than or equal to, it will combine that. JetBrains Mono does have ligatures. So if you do see something weird like that, it's most likely the font. So yeah, Aaron, yeah, for sure. Some of the basic courses on something like C# can definitely be useful. I mean, it is mostly the same. It's just some of those little things. And that's one of the nice things about switching between languages is once you get those little things, then you're just like, all right, I can basically be just as productive in C# as in Unity. So basically that's it. Just some more C# with Unity. So be ready. Make sure you have Unity all installed and all that good stuff. The personal edition, I don't think I mentioned this last time. The personal edition is perfectly fine. You don't need anything more than that unless you plan on making more than $100,000 a year with whatever you create using it, and then they force you to upgrade. So yeah, that's it. So I can stick around if anybody has other questions or has some issues with installing Unity or something. Otherwise, I will see you on Thursday.
Have a good
Have
one,
a good one.
Professor.
So, yeah.
Have a good one.
Have a good one.